All right, trig students, we are in section 10.3 of our book, halfway through the lesson. So we're starting with example 4. Verifying identities. You can use the fundamental identities from this chapter to verify new trig identities. When verifying an identity, begin with the expression on one side. I usually pick the one that looks the messiest. Okay? So begin with the expression on one side of the equal sign. Use algebra and trigonometric properties to manipulate the expression until it's identical to the other side. So you've got some stuff on one side and some stuff on the other side. I pick the messy side, whichever side it is, and I work to get it to look exactly the same as the less messy side. All right, let's try a few. All right, so verify that identity equals, the left equals the right. So I'm opening up my trig book, my algebra book, to those functions that are on a slide or on the book that you, or on the book that you printed out. It looks to me like the left side of this equal sign is way messier than the right side. So that's the side I'm going to mess with. All right? I'm not sure what to do with right now, so I just start messing around. I see secant squared theta minus 1 over secant squared theta. I know that if I separate those fractions... Oh, I did sine. That's a way to confuse the students straight away. Secant squared theta over secant squared theta minus 1 over secant squared theta. Okay, that's equal to this. Now this simplifies to 1, and I have 1 over secant squared theta. I don't really like secant squared theta, so I'm going to change that just a little bit. And these are all tricks you're going to learn as you practice. I wrote sine again. Right there. Secant squared is the same as cosine squared. Ooh, now I recognize the Pythagorean identity. If you remember, it's sine squared theta plus cosine squared theta equals 1. Well, I can solve that for sine squared theta. 1 minus cosine squared theta. So right there I can substitute. This is the same as cosine squared theta. I can substitute 1 minus cosine squared theta equals sine squared theta. And now the left side of my equal sign equals the right side of my equal sign. I am successful. All right, verify another identity. Okay, this one, I don't know which one looks messier, the left or the right. That's a toss-up. I don't know. Let's start messing with the left. It'll be fun. All right, secant x is the same as 1 over cosine x. Tangent x is actually the same as sine x over cosine x. Ooh, these are the same. They're both over cosine x. So let's simplify that. That's fun. Now what can we do? Alright, this one's a little tricky, but I think if I multiply by my complex conjugate pair, my numerator, if I FOIL that, will simplify to 1 squared minus sine squared x. Okay, that's a difference of perfect squares. First times first is 1 outer. negative sine x, inner positive sine x, which cancels out, and last, negative sine squared x. I know that numerator now, the 1 squared, which I don't have to write, minus sine squared x. I can use the Pythagorean identity to make that cosine squared x. But let's look at the denominator. Here I just have cosine x, 1 minus sine x. Now, why did I do that? Well, I know that this numerator can substitute to cosine squared x because of the Pythagorean identity, and this cosine squared x over cosine x will cancel out, and my denominator is going to be left, which is my goal, right? Oops, I don't know why I changed colors, sorry. So let's rewrite this. So I've got one of the cosines gone, and left with cosine x over 1 minus sine x. That was tricky. Honestly, to study for any assessments in this, you're just going to have to practice the problems that you've been given. Practice makes perfect. You're not going to want to sit down for an assessment and try to do one of these for the first time. Okay? You're just not going to. All right. All right. A vertical gnomon, the part of a sundial that projects a shadow, has a height h. The length s of the shadow cast by the gnomon when the angle of the sun above the horizon is theta can be modeled by the equation below. Show that the equation is equivalent to, show that the equation is equivalent to s equals h cotangent theta. So I'm trying to show that these are equivalent, right? And I need a new slide to do that. Right, so we have S equals H sine 90 minus theta over sine theta. And I'm trying to prove that, what's the previous slide say? That is equal to H cotangent, oops. So I need to look at my identities, and I know that the cofunction identities, I'm looking at sine, the cofunction identity I see is sine pi over 2 minus theta equals cosine theta. And remember, pi over 2 is the same as 90 degrees. So let's substitute that out. I have h cosine theta over sine theta. If I look back at that chart, I see that cotangent is cosine over sine. So I've got my left equals my right. That was way easier. But honestly, they're going to get easier the more you practice. You have to trust me on that one, right? All right, a guided practice. Verify the identity. Cotangent negative theta is the same as negative cotangent theta. Well, cotangent negative theta is the same as 1 over tangent negative theta. And if I look at my negative angle identities, I see that tangent negative theta is the same as negative tangent theta. And 1 over negative tangent theta is the same as negative cotangent theta. Verify the identity. Cosecant squared. I think the left side's a bit messier than the right side, so I'm going to go that way. This right here I recognize as the Pythagorean identity. 1 minus sine squared theta is the same as cosine squared theta. Oop, it's an X. Sorry. What is cosecant? I believe that is 1 over sine squared x. Ooh, I see it. I can do cosine squared, I keep doing theta, sorry, x over sine squared x. And I see that is the same as cotangent squared x. So my left equals my right. Yay. Cosecant x, cosine x, cosecant x, tangent x equals 1. Oof. Well, the left is definitely messier than the right. So let's break these things down into what we know. Cosine x doesn't do much. Cosecant is the same as 1 over sine. And tangent is the same as, oh, I got confused. Tangent is the same as sine over cosine. I'm right. Okay. I don't know why I got confused. That's an easy one. All right, multiply across the top and across the bottom. Cosine x, sine x, sine x, cosine x. I'm just collecting everything. Cancel everything you can, and voila, it equals 1. Verify the identity. Cosine squared x minus 1, tangent squared x plus 1. So Pythagorean identity is sine squared x plus cosine squared x equals 1. So cosine squared x minus 1. So if I subtract 1 from both sides, that means I'd have to subtract sine x squared from both sides. So I've got negative sine x squared. That's a little messy, but let's do it. Negative sine squared x. I think I said that backwards last time. Tangent squared x plus 1. I'm looking at my sheet. Tangent squared x plus 1 is the same as secant squared x. I'm at Pythagorean identities. So this is the same as secant squared x. What is secant squared x? That is 1 over cosine squared x. I'm going to move that negative out, get it out of the way, times sine squared x. So if I multiply, I've got sine squared x over cosine squared x with a negative. That equals negative tangent squared x. I was nervous about starting that one. It worked out okay. The key is knowing how to manipulate this Pythagorean identity. Okay, we haven't done one where I've got something minus 1 equals negative the other thing. All right, daily homework quiz. Apparently I left the answers up. This is a great way to practice. I can use any of these on an assessment or any other sort of quizzes that I would give. So yes, if you like some more practice, go ahead and work them out. I can check your work and make sure that they're right. One more slide. There you go. All right, good job.